Hello and welcome to Rex Programming. I'm Tapu. I'm one of the curriculum designers here at Rex, and I'd like to give you a brief demo of what a typical curriculum from Rex might look like. I want to reiterate that this is just a demo. The software we use is often has release updates and patches that force us to change the look on our end. We also often tailor a specific curriculum to a specific client's needs, so not everything you see here today is necessarily final. I'm going to show you three different curriculums that are designed to do different things. The first one up is our Junior Circuits curriculum. The focus of this curriculum is to get students to start learning about electricity and circuits. So we're going to go ahead and take a brief look at lesson one. So every lesson typically will start with something called a teacher's guide. So a teacher's guide will have information that the instructor needs to be essentially successful in the class, the materials that's needed, the setup that's needed, and essentially how to set everything up so that he or she has a successful project. This will typically always come with one of Rex Programming's curriculums. So in here you're going to see quite a few things that are arranged, some worksheets that are necessary for this particular project. Let's go and open up this thing. So this is essentially your PowerPoint slides, which you can always have up. These things will always take you through the project itself, giving out instructions how to do things, how to set things up, things of that nature. So in this particular lesson, what they're finding out are about the basics of conductance and how electricity and current and all that good stuff moves. So they're going to be setting up a few things, and they're going to be testing the conductiveness of various materials, such as different metals, wood, plastic, all that good stuff. So throughout the lesson, they'll have some videos, they'll have some experiments that you're essentially going to go ahead and take part in. And throughout the lesson, of course, you'll have specific things to kind of think about, to kind of test. And once you're all done with the lesson, we encourage open discussion to get the students to think about the activity that they just participated in. So in this case, at the end, we have some questions for teachers to kind of hold an open discussion. Hey, what materials were conductive, what were not, what might have surprised you. So this is just a little demo of what you can kind of expect from this thing. And of course, once you're done with the lesson, if you so wish, we have created some homeworks and quizzes that the students can take if you feel it's necessary. And they're always going to be part of your entire set. So junior circuit curriculum in general is really designed to be hands-on and be and it has a specific a design and standard to it. So again, the focus is electricity, current, understanding the entire nature of how all that moves, and they're going to be doing quite a few projects. It's very heavy project based. We provide those assessments for you to use, but really the main focus of the curriculum is to just build things and test things. So students get to use their imagination, they get to be creative, they get to add on their own personal touch and design to all these things that this entire curriculum uses. Okay, so I'm going to go ahead and close out of that. And the next one we're going to go to is our App Inventor. So the App Inventor is another fun one. So if I go to the main curriculum directory, I'm going to go ahead and open up MIT App Inventor. So as you can see, just like last time, we have quizzes, we have homeworks, homework answers, all that good stuff. This one's a bit more in-depth than perhaps the previous one, because we also have images and sound files and a few other things that you're going to need, because App Inventor is literally about designing a cell phone app. So let's just kind of go into one of the lessons and we can take a look at what exactly is going on. So I'll just open up the Google Docs or Google Slides version. So this is the very first lesson. So clearly it's going to take them through some of the basics. They'll learn how to open up the software. They're going to kind of learn about the basics of what a sprite is, what an image is. They're going to get to play around with all kinds of settings using colors, shapes, building their own sprites, building their own shapes. Again, just a lot of chances for kids to be very creative with what they want to do. Then, of course, once we kind of get into it, they get to start designing basic things. So just the layout of their app, what they want to appear. The first one starts out by doing something very simple, like allowing them to change the color by simply tapping the button. They can import images. They can use Google search to find images. All kinds of neat ways, not only to build the apps, but also explore the internet and learn a little thing or two about how the internet works and how all that stuff works. And of course, this is an intro to programming type of class, and one of the things we do is we allow them to actually explore that programming aspect with block drop programming. So they can go into the settings of this thing, drag out blocks, right? Open it, add on some code, and kind of just see how things work out and what the effects are. So it's all exploration, all project based, and um, just like last time, just like the previous one, this curriculum has a lot of neat things to it. Let me go into this file this time. Okay, and the App Inventor, again, being so heavy on project based, they're essentially going to be creating one app after another. So, calculator app is a lot of fun. The color ball they have a blast with because it almost looks a little bit like ping pong. If you've ever played that game, we actually do have a Pong app, and this is a great way to learn some coding and some basics of logic and foundations of math. It has so many different applications in so many different areas. Okay, and then the piano app is also a lot of fun. They get to work with music and creating their own tones, things of that nature. And the maze game and painting game are also just a lot of fun. So again, just a brief demo of how everything's going to work. And along the way, all these lessons, the solutions, the quizzes, the homeworks, everything is given, everything's provided for. All of that is seamlessly built into the entire curriculum. All of our curriculums are designed for teachers who don't have much, if any, experience any of this to just be able to pick it up, maybe spend a few minutes going over the lesson, and then instantly being able to teach kids with it. All right, and of course the last one, and certainly not the least, Scratch is universally one of the best ways to get young people into the programming game. It's a great introductory course towards just teaching the fundamentals and the basics of logic, math, um, doing just basic things like movements, collisions, um, events, everything that games kind of rely on. So just like last time, we have homeworks, quizzes, projects built in. It's project after project after project. It's all self-paced. Students of all kinds of abilities can move through it at different rates. Typically, after a specific section is over, as a teacher, as an instructor, you may want to formatively assess the student before letting that student move ahead to the second or to the next thing. But this is all about how students want to gear themselves, what they're interested in. Every single project opens up to their creativity and how they want their design. Anyway, I hope that's been a informative presentation on what our company kind of does and what we're about. Shoot us any questions you wish us to answer. Thanks.